Hello everyone. So we have finished the April session of JEE Mains, right? Now we cannot neglect the questions which came from JEE Mains when you are preparing for JEE Advanced upcoming session, right? So that is the reason in this video I bring the top 10 questions from the JEE Mains April 6th session, both shift 1 and also shift 2, and which cannot be skipped for your JEE Advanced preparation and also obviously the BITSAT preparation. Okay, so let us try to see the top 10 questions of 6th April. Look at this question. This is a question from 6th April morning shift, and it is almost a similar question which we have discussed in one of the previous videos also, but with a slight change. Okay, let's try to see the concept again for this one. So, just by looking at the question, it's very clear that we just need to make sure this is lying in between -1 to 1. That is, x plus step x divided by 3 lies in between -1 to 1. And you can cross multiply, and what you get is -3 less than or equals to x plus step x less than or equals to 3. Okay. Now here I'm going to write this step x as x minus of fractional part of x. That's the formula, right? And if I substitute that, it becomes -3 less than or equals to 2x minus of fractional part of x less than or equals to 3. Now I'm going to add 3 to the entire, add fractional part of x to the entire inequality. And I'm going to get something like this. Fractional part of x will be less than or equals to 2x plus 3. This is when you take the left hand side part. And then the right hand side part will be fractional part of x should be greater than or equals to 2x minus 3. Okay. So these are your two inequalities which must be satisfied. Now in the previous video I explained this one by taking some cases, right? Now let us try to see one of the method which is very useful sometimes, that is using graph. Okay. So when you look at the first inequality here, that is fractional part of x is less than or equals to 2x plus 3. We just need to draw the graph of fractional part of x here. So let me draw the fractional part of x graph. We know what the graph of fractional part of x looks like, right? So this is your graph. This is your graph for fractional part of x. Okay, and we know these points as well: -1, -2, 0, 1, and 2. And this highest point is almost 1, not exactly is equal to 1. And then I'm going to draw the graph of this y is equals to 2x plus 3, the right hand side part. Y is equals to 2x plus 3. So you know how to draw the graph of y is equal to 2x plus 3, right? Directly the x-intercept will be -3 by 2. So it will be passing to somewhere here. And then it clearly passes through the point -1 comma 1. So which means this is your graph of the straight line. It passes through the point -1 comma 1. Okay. Now look at the inequality here. We have to make sure the graph of fractional part of x is less than or equals to the graph of 2x plus 3, because we have the inequality like fractional part of x less than or equals to 2x plus 3, right? So I'm going to take the region in which fractional part of x is less than or equals to 2x plus 3 line. That is the graph of fractional part of x lying below the straight line. So this is your required region, and it goes on the right hand side also. Now this is your region. Let's keep it aside because we have one more inequality to solve. Now what is the second inequality here? Fractional part of x greater than or equals to 2x minus 3. So which means I need to draw the graph of y is equals to 2x minus 3. So let's draw the graph of y is equal to 2x minus 3. X-intercept is 3 by 2 somewhere here. And also it clearly passes to the point 2 comma 1, which means the line will be something like this. Okay? But look at the inequality this time. We have fractional part of x greater than or equals to 2x minus 3, which means we have to take the region in which fractional part of x graph is lying on or above the straight line y is equal to 2x minus 3. So I'm going to take that part now. Observe very carefully here in the diagram. It should be greater than or equals to. That is lying above. So this is your region. I'm shading with the yellow part here. Now, so try to understand here. here when you solve this double inequality, we have to make sure both the inequalities are satisfied here. So what is the common region we have shaded here? If you observe the first one, I shaded with green part, and then the next one is shaded with the yellow part here. But what is the region common to both of them? Clearly the interval -1, 2 here. Okay, so that is your required region. That is x belongs to closed interval -1 because it was starting from -1 here and it is going up to open 2 here. Look at the graph, it is going up to open 2. So that is the region which we need, -1 to. Okay. So this is your interval of x which satisfies the domain here. And finally, we are asked to find out the value of alpha square plus beta square. Okay. So this is the advantage with the graph. Look at the next question. This is the question from matrices. And many students might have struggled with this question because generally when you read the properties of determinants and adjoint, this is a property you will frequently learn and also use in many questions. That is det of adjoint of so on up to adjoint of a k times. When this adjoint is there k times, directly you have the formula right? Det a to the power of n minus 1 whole to the power of k, where n is the order of the square matrix. But many students will skip the property for adjoint of adjoint A and adjoint of adjoint of adjoint A. So let's see how to derive these kind of things. Very important for JEE advanced also. Okay. So let us try to look at that. The one property which you will be learning is A into adjoint A. This is a basic formula. A into adjoint of A is equals to det A into I. This is your property. Now in this you will replace A with adjoint of A. If you do that, what you get, observe carefully. Adjoint of A multiplied by adjoint of adjoint A. In the above formula, we are replacing A with adjoint of A. And this is what you are going to get. Okay. But we know the formula very well for this one. Det of adjoint of A is nothing but det A to the power of n minus 1. Okay. Now the next step is to multiply both sides by A. So multiply both sides by A here. And again on the left hand side, you see A into adjoint of A. But what is A into adjoint of A? Simply it is det A multiplied by I. We have the formula above only. And clearly you can cancel out det A on both the sides, one of the term on both the sides. And I into adjoint of A, adjoint of adjoint A will be again same thing, that is adjoint of adjoint A, and that should be is equals to, since you have cancelled one of the determinant A, you will be getting it as det A to the power of n minus 2. And on the right hand side, moreover, you have I into A, which is A. So finally, you have the formula for adjoint of adjoint A, which is equals to det A to the power of n minus 2 multiplied by A. And in this question, if you calculate the determinant of A, you will be getting it as -1. I'm leaving the calculation part to you. Det A will be is equal to -1, and here n is equal to 3 because it is a 3 by 3 matrix. So directly you have -1 whole to the power of 3 minus 2, which is 1. So finally what we get is adjoint of adjoint A is equals to -A. Okay, because already A is given to you. But look at the tricky part here. They have not stopped at adjoint of adjoint A. They are still asking you to find out adjoint of adjoint of adjoint A. I think now you understood what to do. That is, from the previous formula which we have derived just now, again, once again, replace A with adjoint of A. So that is the trick here. So if you know this trick, you can find out the formula for any times adjoint repeated. Okay, very, very important for advanced. Adjoint of adjoint A, because I'm replacing A with adjoint of A. So that should be is equal. So right hand side part is what? Determinant of adjoint of A to the power of n minus 2 multiplied by, again, A is replaced with adjoint of A. But clearly this is the base on the right hand side, det of adjoint of A, for which we know the formula again. That is det A to the power of n minus 1 whole to the power of n minus 2 multiplied by adjoint of A. So finally what we have is det A to the power of n minus 1 into n minus 2 multiplied by adjoint of A. And finally, we know what is det A in this case, which is -1 to the power of 3 minus 1 is 2 and 3 minus 2 is 1 and multiplied by adjoint of A. And finally, you get this is equals to adjoint of A in this question here. So And this is the reason we should know this property. So make it as a property and try to remember adjoint of adjoint A is delta to the power of n minus 2 into A, and adjoint A will be delta to the power of n minus 1 into n minus 2 into adjoint of A. Now I'll leave the solving part to you, because look at the required question. We have a matrix equation, that is A square plus alpha into adjoint of adjoint A plus beta into adjoint of adjoint A is equal to some matrix is given to you. So once you find out what is this adjoint of adjoint A, put this minus A back in the given matrix equation, and again calculate adjoint of A, take it and substitute in this equation. Clearly equate the elements on both the sides of the equation to find out the values of alpha comma beta. So once you know this property, it's a very simple question. Okay, na? So that is why make it as a property which is potentially very important for JE Advanced and also BITSAT. Okay, let's take the next question. Now this is a very good question asked from 6th April JE Mains and very important for the upcoming advanced session also. Here it is a combination of conic section and also quadratic equation and location of roots in quadratic equations. Okay, very important. It is covering so many concepts, right? So first thing, given that E1, E2 are the roots of the quadratic equation and the set of values of A for which E1 and E2 are the eccentricities of a hyperbola. So if E1, E2 are eccentricity of a hyperbola, then we can say that E1 should be greater than 1 and E2 also should be greater than 1 here. Okay. Now let me take the given quadratic as f of x is equals to x square minus ax plus 2, and then clearly it's upward parabola, right? So given that this polynomial has the roots as e1 comma e2, but what is that meaning here? Both the roots of this quadratic are greater than 1. So let's try to imagine the possible graph here. So let me take the value 1 here on the x-axis. Now given that both the roots of this one are greater than 1, and we know that it is an upward parabola, so which makes the only possible graphs as this. Only these two are the possible graphs here. Okay. Now, if you look at the graph, first thing is very clear. We have to apply delta greater than or equals to 0. Okay. Equal to 0 is also possible. You have to be careful. So for this polynomial, what is delta here? Which is clearly a square minus 8 greater than or equals to 0. And you get from here, a belongs to minus infinity to minus 2 root 2 closed union 2 root 2 to infinity. Okay, so this is your delta greater than or equals to 0 solution. But at the same time, you can notice that this vertex of this one minus b by 2a should be definitely greater than 1. That is also one condition, because the vertex of the parabola clearly lies right side of the x is equal to 1. That is why minus b by 2a should be greater than 1. And what is the condition here? Minus b by 2a is nothing but minus of minus a divided by 2 into 1 greater than 1. So which makes it finally a greater than 2. This is one more conclusion, and this was the first one. But along with this one, these two are not sufficient. Along with this one more thing is very clear here. The parabola, the graph at x is equal to 1 is clearly lying above x-axis, which means f of 1 should be strictly greater than 0. It can't be equal to 0 also here. It should be greater than 0. So let's calculate f of 1 as per the assumed polynomial. It is 1 minus a plus 2 greater than 0. So which makes finally it is a less than 3. Now, just to take the common part of all these here, a greater than 2, this is first inequality, this is second inequality, this is third inequality here. So, which will give you the values of a as a belongs to, clearly the common region would be closed interval 2 root 2 to open 3, because it should be less than 3 as per the first inequality. Okay. So this is your case 1 answer. Given that this is alpha comma beta, so you got alpha is equals to 2 root 2 and beta is equal to 3. Okay, so this is the first part. But the question is not over yet. That's the beautiful thing about this question. It is involving multi-concepts. Now, the set of values of A for which E1 and E2 are the eccentricities of a hyperbola and an ellipse is gamma comma delta, gamma comma infinity. Okay, so which means there is a part 2 for this question, and here in this case E1 is for hyperbola, so it should be greater than 1, and whereas E2 is for ellipse, which means E2 should be less than 1. And again, the polynomial is not changing here, so it's an advantage x squared minus ax plus 2. Okay. Now e1 comma e2 are the roots of this polynomial. But what's the main thing here? If you try to plot the graph and it is an upward parabola known to you, let me mark the value 1 here. Okay. And the main condition here is one of the root is greater than 1 and other root is less than 1, and also we know it is a upward parabola, which means the only possibility for the graph as this. Only possibility for the graph is this. Now, based on this one, what are your conclusions now? Delta should be strictly greater than 0 because it can't be equal roots as well. So if delta greater than 0, just now we have solved it. So let us not waste the time. You get a square minus 8 greater than 0. You get the same inequality as the previous one, but with an open bracket here. So minus infinite to minus 2 root 2 union 2 root 2 to infinity. And then along with this one, look at the value of f of 1 here, because at x is equal to 1. Clearly, the parabola is strictly below the x-axis, so which makes f of 1 less than 0. So what is f of 1 here directly? 1 minus a plus 2 less than 0, which makes a greater than 3. A greater than 3. Now finally, only these are the two conditions, right? So what you must do, you should take the common part of these two intervals, right? The first one is this, and this is your second one, a greater than 3. And what's your common part? Obviously, a belongs to 3 to infinity. As you can see, we have given you the interval as open gamma to infinity. So finally, we have got the values of alpha, beta, which are 2 root 2 and 3, whereas gamma is nothing but 3 here as per the second part. Okay, so as I told, it's a multi-conceptual question. So this kind of questions will be asked in JEE Advanced, where it will be taken from multi-chapters and also multi-concepts. Okay, so try to be careful. Let's take the next question. This is a question based on 3D geometry, that is lines involving 3D geometry. And once again, multi-conceptual question because a lot of things are involved here. Let's try to read the question. Point P is the image of point Q with respect to the straight line L. So let me take the diagram first of all, just to get some clarity. So this is your point P here, right? This is your point P, which is already given to you. And they said that Q is the image of this point. But what is the concept of image actually? If you join this image and original point, it should be perpendicular to the given line. And L is also given to you in the question, right? And then this, wherever this image line is meeting the original line, that should be the foot, nothing but the midpoint, right? So that should be the midpoint. That is, these two are of equal lengths here. Okay, so what I'm going to do is I'm going to find out the DRs of this PQ, and then I'm going to take the DRs of L, and since both are perpendicular, A1 A2 plus B1 B2 plus C1 C2 is equals to 0. Moreover, I have to find out the midpoint of PQ also, right? Because this is foot is the midpoint in this case. So let me take the midpoint directly, and let's call it as some point R. Okay, point R is nothing but midpoint, that is a by 3 plus 1 by 2, which will give you a plus 1 divided a plus 3 divided by 6 comma 0 plus 6 divided by 2, which will be 3. And then next a plus c plus a, that is 2a plus c divided by 2, right? So this is your midpoint, and now this midpoint R is clearly lying on the line, so it has to satisfy. That's one condition, obviously. So let's put that there. You get a plus 3 divided by 6 is equals to 3 minus 1 by 2 is equals to 2a plus c by 2 minus a plus 1 whole divided by b. Now you know what to do very well. That is, if you directly equate these two, you get one of the value, that is a here, because in the first two terms, only a term is there and constant terms are there, right? So if you properly calculate, you would get a is equal to 3. I'm leaving the calculation part to you. And similarly, if you equate these two also, what would you get? You get one condition in terms of a and c, sorry, b and c, because obviously you know the a value. You will take it and put it here. And if you solve that, you get one more condition, that is c plus 2 is equals to 2b. Okay, let us take it as some condition number 1. I hope you get it there. You get that point there. That is just a solving part. I'm leaving it for you, right? So I substitute the midpoint in the line. But as I told, along with that one, I'm going to find out the DRs of this PQ here. So let's calculate the DRs of the PQ. We have seen this many times in the previous videos also. A by 3 minus 1, comma 0 minus 6, comma a plus c minus a will be c. So these are your DRs of PQ. Similarly, we have to get the DRs of line L also, but what do we know? The denominators are nothing but the DRs, right? So which will give you 1, comma 2, comma P. So you have the DRs of the two lines, but clearly this line L and PQ are perpendicular to each other. So directly apply the condition, that is a by 3 minus 1 multiplied by 1 plus minus 6 multiplied by 2 is equals to, sorry, plus C multiplied by B is equals to 0. Now already you have the value of A. Take that and put it here, and you get one more equation in terms of B and C. So try to take it as equation 2. So clearly two equations are there, two unknowns are there. Now you know what to do. Directly solve for the values of A, comma C. And if you solve it properly, you would get C is equals to 4 and then B is equal to 3. Okay, so you got the values of A, comma B, comma C here. And that's the first part of the question, one concept which is involved in this question. But along with that, read the question now. Alpha, comma beta, comma gamma is at a distance of 2, comma root 14, comma, sorry, 2 into root 14 from the foot of perpendicular Q on the line L. Okay, so clearly the point R is nothing but the foot from the point Q on the line L. And then they said that S is a point on the line L which is given by alpha, comma, beta, comma, gamma. And then they said that the distance between S and R is 2 root 14. So let me write down S in SR is equals to 2 root 14. But you know very well how to assume a point on the line, right? We just equate it to some constant K. So let us write down the equation of the line which is x by 1 which is equal to y minus 1 by 2 which is equal to, since we have got already A is equal to 3, let's put that, and you get your equation as z minus 2 divided by 3, and you will take it as lambda, and finally you can assume your point on the line, that is lambda comma 2 lambda plus 1 and 3 lambda plus 2. So this is your point S. But what is the condition actually? S R distance is equal to 2 root 14. But what is the point R here? Just now we have written, right? The point R. So if you look at this, point R is here, but you know the values of A and C. You can put that there, and you can find out the point R here, which will be 1 comma, because A is equal to 3, right? 1 comma 3 comma. If you put A and C values here, you get this as 1, 3 and 5. So finally, the distance between these two values, these 2 points, SR is given as 2 root 14. Now you know what to do very well. Directly apply the distance formula, square root of lambda minus 1 whole square plus 2 lambda minus 2 whole square plus 3 lambda minus 3 whole square, which is equals to 2 into square root of 14. So finally, square on both sides, you get a quadratic equation. Solve for the values of lambda. Okay. And once you get the values of lambda, you can substitute back in the point S to get the required answer, because finally they are asking the values of uh, alpha square plus beta square plus gamma square. So that part you can do it, right? Get the values of lambda, take it, substitute it back, and finally you get your point S, which is required in the question. Okay. Next question. This is a question from functions chapter, and also it is involving integration. So once again, it is a multi-conceptual question. Right. So many students might have got confused with this question, and they might have skipped it because it was looking somewhat complicated. But if you get the right idea, it's a very simple question actually. So this kind of tricks are very, very important for the upcoming JEE Advanced and also BITSAT. Okay. So the main word which you have to focus in this question is strictly increasing and also bijective function. So we know what is a strictly increasing function and also what is a bijective function. So if you try to look at the mapping in this function, this is set A, let's call it set A, and this is the set B. And let's take the elements here. This is set B. Now in set A you have 1, 2, 3, 4, and in set B you have 1 E, E square, and also E cube. Okay. So this is your function f mapping, but they gave that the function is a strictly increasing function. But what is the meaning of a strictly increasing function? That f of 1 value must be less than f of 2, must be less than f of 3, must be less than f of 4. What's the reason? As the inputs increase, outputs also must be strictly increasing, so which means this is your inequality that must be satisfied. And also, since it is bijective, it must be both 1 1 and also an onto function. So which means the one and only one possibility is you can map 1 to 1, 2 to e, 3 to e square, and 4 to e cube. And what's the reason for that? If you try to map, let's say 1 to e, what happens? F of 2 must be mapped to the next element e square or e cube. Let's say you're mapping to e square. And then next you have to map 3 to e cube because f of 1 less than f of 2 and so on, right? But clearly, in this case, the element 4 will be left without mapping, which is not even a function. So that is the reason the one and only one possibility for the mapping here is this. So directly you can notice that is f of 1 is equals to 1, f of 2 is equal to e, and f of 3 is equals to e square, f of 4 is equals to. Now the next part is about the function g here. So let's do the mapping for the function g also. Now you know what to do, right? So there is a set C and D for the function G, and the inputs are 1 E, E square, and EQ, and the outputs are 1 by 4, 1 by 3, 1 by 2, and 1. Okay, and this is your mapping G here. But in this case, they said that the function G is strictly decreasing. Strictly decreasing means the inequality should be reversed, that is, G of 1 should be greater than g of e should be greater than g of e square should be greater than g of e cube. That is, as the input increases, the values must decrease here. And that is the reason the one and only one possibility is g of 1 should be mapped to 1. Okay. And then g of e should be 1 by 2. E square should be 1 by 3 and e cube should be 1 by 4. This is the only case where the order of the elements will be reversed here. Observe carefully, g of 1 is 1, g of e is 1 by 2. So clearly the outputs are in strictly decreasing order. Okay. Now you know what to do very well. Because if you look at the function, our required part is phi of x is equals to f inverse of g inverse of 1 by 2 whole to the power of x. Okay. But if you look at the function g here, can I say that directly g of e is equals to 1 by 2, the functional value? But if g of e is equal to 1 by 2, I can say that g inverse of 1 by 2 should be is equal to e. So take that value of e, put it here, and we get the function as f inverse of e to the power of x. But where is this f inverse of e here? Clearly, f of 2 is equal to e, right? So which makes f inverse of e is equals to 2. As you can notice, f inverse of e is equals to 2. From the mapping only you can tell, right? And that's how you get your function 2 to the power of x. Okay. And finally, what is the required part? Integral 0 to 1 phi of x, that is 2 to the power of x minus x square of dx. Okay, now you know how to solve the integration part. Okay, as I told, this is a very interesting question which is involving concepts of increasing decreasing functions also, and also integration, right? So try to be careful here. Let's take the next question. This is a question for the matrices, and this is a question where students will generally waste their time by trying to find out the pattern for a to the power of 99 here. As you can see, it is involving b is equal to a power 99 minus of identity matrix, right? So don't try to find out the pattern for this kind of question. We have other simple method using binomial expansion. That's the trick here. So try to follow it carefully. The given matrix is A. I am going to split the matrix like this. Look at this 1 0 0 0 1 0 0 0 1, and then plus 0 0 0 3 0 0 3 3 0. Okay. Now what I am going to do is, this is clearly the identity matrix, first one, and I am going to take this matrix as some matrix C. So that I have an expression A is equals to I plus C. But what I have to find out is A power 99. So I can write this as a power 99 is equals to I plus c to the power of 99. But you know how to expand the binomial expansion, right? That is 99c0 multiplied by I to the power of 99 plus 99c into I to the power of 98 multiplied by C plus 99C2 into I to the power of 97 multiplied by C square plus 99C3 into I to the power of 96 multiplied by C cube and then so on. Okay. And the reason I'm writing these many terms is just to make you understand that the matrix C here is a strictly triangular matrix. For a strictly triangular matrix, what happens is C cube will be is equal to 0. Okay. C square you can find out by doing C into C, but CQ will be definitely is equal to 0 for such kind of strictly triangular matrices. But what do we know here? If C cube is 0, obviously C power 4 everything is going to be 0, right? And that is the reason starting from this term, every next term is going to be 0. So this means is that only a to the power of 99 is equal to 99C0 is 1 multiplied by I power 99 is I plus 99C1 is 99 multiplied by C, and then finally we get 99C2 into C square. Okay, and the required part is matrix B actually, which is A power 99 minus of I. You can take it to the left hand side. Finally you have the required matrix B. A power 99 minus I is equal to 99 into C plus 99 C2 into C square. And this is given as your matrix B. But you know how to do the remaining calculation, right? Because matrix C I have mentioned here already. And C square you can find out, put that and equate it to B. Finally, what they are asking is B31 plus B32 divided by B21. So what is B31 here? Element belonging to third row and first column. So after finding B, you can find out whatever they are asking in the question. Okay. Let's take the next question. This is one of the questions which is very important for JEE Advanced also, because this kind of questions will be asked frequently where you have to find out the composite functions of two functions and then check the continuity or also differentiability. So since some of the students might get confused in writing composite function, let's try to see the concept behind it. So first thing is you need to write down the function g of x, g of f of x here. So what is g of f of x? Simply in the entire function g of x, replace x with f of x. So what we get is f of x minus 8 to the power of 1 by 3. This is when f of x is less than 0. Similarly, the other one is f of x plus 4 to the power of 1 by 2. This is when f of x is greater than or equals to 0. Now you know what to do. That is put f of x in each case separately. So what we can do is finally g of f of x is equals to, so let me put f of x as x cube plus 8 first of all. So this becomes x cube plus 8 minus 8 whole to the power of 1 by 3. Putting f of x here in the case 1. Okay. And then this is when f of x is less than 0, that is x cube plus 8 is less than 0. And also since we are taking x cube plus 8, it should be x less than 0. Okay. It's a combination of these two. Similarly, let me put this x square minus 4 in the first function, that is x square minus 4 minus 8 whole to the power of 1 by 3, putting this second case of f of x in the first case of g of f of x. So this will give you x square minus 4 less than 0, and also since you are choosing x square minus 4, it should be x greater than or equals to 0. Now let's take the second case of g of f of x and put f of x in that. Okay, so let us try to do that. First, I'll put x cube plus 8 there. So that becomes x cube plus 8 plus 4 to the power of 1 by 2. This is when x cube plus 8 is greater than or equals to 0. And also since you are choosing x cube plus 8, it should be x less than 0. Now put the second case of f of x in, the second case of g of f of x, which will give you x square minus 4 plus 4 to the power of 1 by 2. This is when x square minus 4 is greater than or equals to 0. But since it is second case of f of x, it must be x greater than or equals to 0. Now you know what to do very well, because this is x cube plus 8 less than 0. If you simplify, what would you get? X cube less than 8, that is x less than minus 2. So you should take the common part of x less than minus 2, your answer, and then x less than 0. So what is the common part? Clearly x less than minus 2. That's your first interval. Then what is the meaning of x square minus 4 less than 0? That is x belongs to minus 2 to 2, and simultaneously x must be greater than or equals to 0. So what's your common part? Obviously x belongs to 0 to 2. Okay. And then next case, this is x cube plus 8 greater than equals to 0, which will obviously give you x greater than equals to minus 2, but taking common part with x less than 0 will give you x belongs to close to minus 2 to open 0. Okay. And then similarly, the last case, that is x square minus 4 greater than equal to 0, means x belongs to minus infinity to minus 2 close to union close to 2 to infinity, taking common part with x greater than equals to 0, which will give you x belongs to 2 to infinity. And then finally you can write your function g of f of x here, which should be is equal to, so what's your case 1? Plus 8 minus 8 gets cancelled. X cubed to the power of 1 by 3, which will be x. First interval is x less than minus 2. Second case is, it is x square minus 12 to the power of 1 by 3. This is when x belongs to close to 0 to open to. Okay. And then similarly, the third case, x cube plus 12 to the power of 1 by 2. This is when x belongs to minus 2 to open 0. And final case is plus 4 minus 4 gets cancelled. X square whole to the power of 1 by 2, which is actually mod x. But since x belongs to 2 to infinity, it should be x directly. And this is a case for x belongs to close to 2 to infinity. Okay. Now, since you have constructed g of f of x function, at last what you are supposed to check, points of discontinuity of g of f of x, right? So you know what to do very well now, because the definitions are changing at what points here. Clearly it is changing at the minus 2, 0 and also 2. So let's check for the continuity of this function at these 3 points and try to test whether it is continuous or also discontinuous. Okay, now so this is how you must do this kind of questions. Be very careful. Let's take the next question. It is a very interesting question from binomial theorem chapter. And again, once again, many students try to waste their time in this question. And for such question, we have some simple tricks which we need to follow. So look at the question, 1 minus x cube whole to the power of 10 is equals to sigma r is equal to 0 to 10 a r multiplied by x to the power of r multiplied by 1 minus x to the power of 30 minus 2r. So we have to do the smart work here. That is, we'll try to simplify the left hand side part first of all. Okay. So since I have 1 minus x cube, I'll try to recall the formula of 1 minus x whole cube, which is 1 minus x cube minus of 3ab into a minus of b, so which is 3x into 1 minus of x. But what I want is 1 minus of x cube, right? So let's try to separate here. What we get is 1 minus x cube is equals to 1 minus x whole cube and plus 3x into 1 minus of x here. Okay. But we want 1 minus x cube whole power 10, right? So let's raise to the power of 10, 1 minus x cube to the power of 10 should be is equals to, this is clearly 1 minus x cube whole 1 minus x whole cube plus 3 into x into 1 minus x whole to the power of 10. Okay. Now, what I'm going to do is treat the right hand side part as the expansion of some x plus y to the power of n. Okay. But we know what is the general term for this one, right? Which is clearly NCR into x to the power of n minus r multiplied by y to the power of r. Okay. So if you look at that, in this case, I'm going to write down the general term now. So let me write down, which is 10CR multiplied by x to the power of n minus r. Here x is 1 minus x whole cube and to the power of n minus r, which is 10 minus r multiplied by y is clearly 3 into x into 1 minus x whole to the power of r. Okay. Now let's try to simplify here. This is 1 minus x cube whole to the power of 10 is equal to 10CR multiplied by 1 minus x whole to the power of 30 minus 3r multiplied by, this will be 3 to the power of r into x power r into 1 minus x to the power of r. Now let's combine few terms here. I can combine these two terms, right? And let's separate these terms also. Take this 10CR multiplied by 3 to the power of r multiplied by x to the power of r multiplied by, finally what we have is into 1 minus x whole to the power of 30 minus of 2r. 30 minus of 2r. Okay. So this is the advantage by doing in this method here, because as you can see, the right hand side is also in a similar form. Right hand side here is also in a similar form. So we have the same term, that is x power r multiplied by 1 minus x to the power of 30 minus 2r on both the sides in general terms. So let's equate the remaining part. So coefficient is AR in the given question, but here the coefficient that we have got is 10CR multiplied by 3 to the power of r. So that is your value of 8 to the power of r finally. Okay. And then look at the required part. We need to find out 9 into a9 divided by a10. So once you write down ar by using this trick here, you can find out a9 and also a10 and find out the required answer. Okay. So try to go through this method. So this kind of tricks are very important for JEE mains and JEE advanced and also upcoming BITSAT session. Okay. Let's take the next question. This is a question from functional equations and also involving definite integration here. And this question, many students might get stuck here, because when you look at this given functional equation, directly you might think that f of x is equal to x power n, which is a standard functional equations formula. Whenever we have f of xy is equal to f of x into f of y, you directly take f of x is equal to x to the power of n, but that will not work out here, because look at that. If you take f of x is equal to x power n, f of 0 is equal to 0. But they said that f of 0 is not is equal to 0, which means it won't work out. That's the trick part here. That is why just to try to follow the method which I gave you in the earlier videos also. Okay, I have given two cases in two of the videos. Okay, so let's partially differentiate with respect to x here. So if you differentiate partially with respect to x, y is a constant. So this will be f dash of xy multiplied by y is equal to f of y is a constant. So f of y into f dash of x here. Now simply put y is equals to 0 in this equation. You get 0 is equals to f of 0 multiplied by f dash of x. But given that f of 0 is not equal to 0, you can cancel it out. What's your remaining equation? F dash of x is equal to 0, which means the derivative of the function is always 0, which makes the function f of x as a constant function. That's the important part here. Okay, f of x is a constant function. So since f of x is equal to k, put this back in the given functional equation. So f of xy is also is equal to k. So k is equal to f of x is k, f of y is also k. So finally we get k square is equal to k, which means k is equal to 0 or 1. But once again, you can't take k is equal to 0, because given that f of 0 is not 0. So which means the only possibility is k is equal to 1. So finally you got your function f of x is equals to 1. Okay. Now you can take this f of x function and substitute in the given differential equation, that is x square into g of x, which is equals to integral 0 to 1 t square into f of t, but f of t is 1 here, that's the advantage, plus t into g of t of dt. Okay, now you have to find out the function g of value g of 2, right? Now you know what to do very well, that is directly differentiating on both sides. X square into g dash of x plus g of x multiplied by 2x is equals to, on differentiating right hand side by using Leibniz tool, what would you get? X square plus x into g of x. Okay, and finally you know what to do. It's a clear differential equation, right? Now you know what to do, that is it will be x square multiplied by g dash of x. You can bring this to the left hand side, which makes it x into g of x, which is equals to x square. Now finally it's a linear differential equation, because if it is like x square into g dash of x is nothing but dy by dx plus x into y is equal to x square. Divide both sides by x square. What you get is dy by dx plus y by x square is equal to x square. It's a clear linear differential equation. Here you know what to do. We have the formula for solution of differential equation in LD, right? So that's the part here. So this differential equation part you can solve. You can solve, which is very easy. But the main thing here is solving the functional equation, which is very important. Okay, so try to keep in mind. and don't blindly take f of x is equal to x power n always for such functional equations. Okay. Let's take the next question. This is also one of the interesting questions from that 6th April JEE main session, and it is potentially very important for upcoming JEE advanced also. So it has two parts. First thing is we have to find out the ellipse equation. That part is very easy. Let's do it. Ellipse has directrix x is equal to 9. So x is equals to 9, and we know the directrix equation actually as a by e. So we get one equation, a is equals to e times of 9, and then eccentricity is 1 by 3. So E is equal to 1 by 3. Take it and put it here, and you get finally A is equal to 3. Okay. And they said that one of the focus is alpha comma 0, where alpha is greater than 0. Okay. But you know that for a standard ellipse, x squared divided by a square plus y squared divided by b square is equals to 1. That is, focus is plus or minus ae comma 0, but since here they are saying alpha is greater than 0, your required focus is ae comma 0. So a is 3, e is 1 by 3, so finally you get the focus as 1 comma 0. Okay, so let us mark it. Now look at the interesting part here. We have to find out the locus of midpoint of the chord that passes through the point P alpha comma 0. Okay. So here they are saying this focus is point P, right? So let us take it as point P as per the given question. Now, if you draw the diagram, you will get half of the idea. So this is your point P, that is the focus, alpha comma 0, P 1 comma 0. Now they said that there is a chord passing through it. Let's take it something like this. This is the chord which is passing through the point P. Let's take it as some chord AB here. Now what we have to find out is the locus of midpoint of this chord. Okay, so let's see the calculation part. First of all, I'll assume the locus point as some point L, and let me take the locus point as usually h comma k, right? So let me take the locus point as h comma k. Now the important part here is for the chord AB, this L is acting as a midpoint. So I'm going to write down the equation of the chord AB here, because we have the very important formula. Whenever we have the midpoint of the chord, to write down the equation of the chord, what is your formula? It is directly S11 is equals to, sorry, S1 is equal to S11. This is your formula to write down the equation of chord whose midpoint is known to you. Okay. So what is your ellipse equation here? Which is x square divided by a square plus y square divided by b square is equal to 1. But already you got a is equal to 3, which will give you x square by 9 plus y square divided by, you have to calculate b value also. So since you know a and also e, you can calculate what is b here. So if you calculate it properly, you will get b square is equal to 8. Okay, I'm leaving the calculation part to you. So take that b square, put it here, and this is your ellipse equation. Okay. So with respect to the midpoint L h comma k, let's write down S1 here, which is clearly hx divided by 9 plus ky divided by 8 minus 1 is equal to, what is S11 with respect to the point h comma k? H square divided by 9 plus k square divided by 8 minus 1. So clearly this will be cancelled out, and the remaining part is your equation of the chord AB whose midpoint is L h comma k. But interesting part is here we have to find out the locus, right? As we can see in the diagram, this chord AB is also passing through the point P. That is, the point P 1 comma 0 has to satisfy this equation here. So let us substitute that here. So what we get is h divided by 9 plus 0 is equals to h square by 9 plus k square divided by 8. So finally, you know what to do to find out the locus. That is, simply replace h comma k with x comma y. So what you get is x square divided by 9 plus y square divided by 8 is equals to x by 9, or you can bring it to the left hand side and write it as minus x by 9 is equals to 0. So this is your final equation of locus of midpoint of the chord which is passing to alpha comma 0. Okay. So this is the interesting part, that is you need to get the idea of taking the midpoint as h comma k and then writing down the equation of AB is important using the formula S1 is equal to S11, and also after that you need to notice that that chord AB is also passing through the point 1 comma 0 as per the given question. Okay, so this is the question, right? So these are the top 10 questions from 6th April JEE mains session, both morning and also afternoon shifts, which you must know before you go to your JEE advanced and also BITSAT preparation. Okay. In the next video, I will take the top 10 questions from 8th April JEE main session also, which are potentially important for upcoming JEE advanced and also BITSAT sessions. Okay. Right. Thank you.